Hey guys, so today I'm going to be teaching you how to divide whole numbers using 3 different strategies. The first strategy that I'm going to give you is long division. So just like in my multiplication with whole number video, I'm giving you the most efficient and quickest way first. The second strategy that I'm going to show you is going to be finding partial quotients, and the third strategy will be using an area model. Our 5th grade standard says that we need to know how to multiply up to 4-digit dividends with 2-digit divisors. So that could be a 4-digit number divided by a 2-digit number. Because we also see 4-digit divided by 1 digit in 5th grade, I'm going to start off by showing you how to do those first. If the problem we were given was 1,406 divided by 2, the way we would set it up with long division is we need to make a division bar. Our bigger number, the dividend, goes on the inside. That's the number that's being divided, is the dividend. The number doing the dividing is the divisor, which will go on the outside of the division bar. Just like multiplying with the standard algorithm, using long division is just a process. We take our divisor, the digit that's on the outside of the division bar, and work our way in digit by digit. And what I mean by that is we want to see how many times our divisor can fit into that number. So for example, here we have 2 and 1. If 2 can go into 1, then I would write that number above the 1. However, in this problem, 2 cannot go into 1 because 2 is bigger. So in those cases, we need to go over 1 and use both digits. So now we're not just seeing if 2 can fit into 1, we're seeing if 2 can fit into 14, which it can 7 times. So because we used both digits instead of just the 1, that 7 is going to go above the 4. So we just showed that 2 can fit into 14 7 times. And now we've got our process started. So we can say 7 times 2 is 14. Subtract. 14 minus 14 is 0. Every time we subtract, we have to drop down the next number. And we start the process all over again. If 2 could fit into 0 a certain number of times, then we would put that number above the 0. However, 2 cannot fit into 0, so it can fit in 0 times. Multiply. 0 times 2 is 0. Subtract. Every time we subtract, we drop down that next number. So now we've got a 6. Start the process over. 2 can fit into 6 3 times, so there needs to go a 3 above the 6. 3 times 2 is 6. Subtract 0. And there's nothing else to drop down. That's how we know that we're done. This 0 right here at the very bottom just shows us that we have no remainder left over. 2 was able to fit into 1,406 exactly 703 times. Now I'm going to show you that same division problem, but using a different strategy, partial quotients. The way we set up partial quotients is very similar to long division. The bigger number, or our dividend, goes on the inside of a bar. And the smaller number, the divisor, goes on the outside of the bar. While I call this strategy finding partial quotients, I've also heard people call it the Big 7 method, which I love because it does turn into a big 7. The thing I like about partial quotients is there's really no right way to do it. It's using mental math that you know to help solve this problem. So our goal with partial quotients is to chip away at our dividend little by little by little until we get as small as we can. So we need to multiply 2 times something to get very close to this big number right here. This is where mental math strategies really come in handy. I tell my students to start off with thinking of multiplying by tens. So 2 times 10, 2 times 20, 2 times 30, whichever one would get us closest to this number. But in this situation, 2 times 90 only gets us to 180, which isn't very close to this number at all. We would have to do a lot of work if we were to use 90. So in cases like that, where it doesn't get us very close, I bump up to the next place value. If we were to multiply 2 times hundreds, 100, 200, 300, 400, we'll see that 2 times 700 gets us to 1,400, which is very close to our dividend. So that's the number that I'm going to go with. I'm going to put my 700 on the outside of the bar. This is going to be where our partial quotients are, which is very similar to finding partial products like in multiplication. It's just part of the quotient or part of the final answer. Then all we have to do is use our mental math strategies. We know that 2 times 7 is 14, plus the 2 trailing zeros on the end would be 1,400. And we need to subtract and see what we're left over with. All that we're left with is a 6. So that leaves us off pretty easy. Now all we need to do is ask ourselves 2 times what gets us close to or directly at 6, and that would be 3. 2 times 3 is 6. Subtract, and we're left with a 0, which just means that we were able to get it down all the way to 0 with nothing left over by dividing by 2. All we have to do with our partial quotients on the side are add them together. 700 plus 3 would be 703, which is our final quotient. I have seen partial quotients laid out just a little bit differently, where the partial quotients themselves are stacked on top of the division bar instead of on the side. So just be careful of that if you see it that way. Area models with division are a little bit trickier than multiplication because you're kind of working backwards. But you'll see, hopefully, that it is very similar to just finding partial products. So we're going to start with just making a box. We want to make sure that we've got enough room in case this box needs to extend, which it surely will. Typically, it's better to use horizontal paper when doing area models just because you're going to need that wide space. For an area model, we're going to put our dividend, the bigger number, inside the box on the top. And our smaller number, the divisor, is going to be on the outside of the box. So the goal here, just like in finding partial quotients, is to get our dividend down as small as we possibly can get it so that it's smaller than the divisor or at 0. So we need to think back to those mental math strategies that I was just talking about to figure out what can get us closest to this number by multiplying by 2. In the previous strategy, when multiplying by tens, we found out that that wasn't going to get us very close. When we multiplied by hundreds, we noticed that 700 was going to get us extremely close, only 6 away. But just to show you that there really is no right way to do this, it's just mental math strategies, I'm going to illustrate that by picking a different partial quotient to start off with. Instead of 700, I'm going to pick 500. So then we just start our process over again. 500 times 2 is going to be 1,000. Subtract to see what we're left over with. Since we can fit 2 into 406, we can keep going with this number. 500 isn't going to be our final quotient, so I need to add another box. Whatever we're left over with then goes up to the top of the next box and we start over again. Using mental math strategies, the closest that we're going to get to 406 is 2 times 200, which is 400. Subtract and see what we're left over with. 2 can still fit into 6, so that means we need to make another box. We're going to keep going until the number that we're left over with is either 0 or smaller than our divisor, which would indicate that it's a remainder. Start the process over again. 2 can fit into 6 3 times. 3 times 2 is 6. Subtract. And now that we're left with 0, we are done. There is no remainder. So what we can do is add up our partial quotients on the top to get our final quotient. So just like in our first strategy of long division, our second strategy of finding partial quotients, Our quotient in an area model is still 703. All right, so now we've got 4-digit dividends with 2-digit divisors. So this is going to be a 4-digit number divided by a 2-digit number. We've got 4,182 divided by 35 for the next 3 strategies. The first one that I'm going to start with again is long division, just because it's the quickest, most efficient in my opinion. I think it's a great strategy to know for state testing whenever you have to do something quickly or in a pinch. Just like before, we need to start out with our division bar. Our dividend, the bigger number, is going to go on the inside of the bar. And our divisor, the smaller number, is going to go on the outside of the bar. So if you remember me saying it's just a process, we start with the number that's on the outside of the bar. In this case, we've got 35, and we're going to scooch in digit by digit and just see how many times it can fit into that number. So our first digit is 4. 35 cannot fit into 4. It's much bigger than that. So we're going to use both numbers. Now we've got 41. 35 can fit into 41, but only one time, because 35 times 2 would be 70. And we don't have that much. So the 1 goes above that second digit in 41 since we used both digits. If 35 could fit into just 4, then that number would have gone above the 4. Then we multiply. 1 times 35 is 35. Subtract. Every time we subtract, we drop down the next digit. I know that 35 times 2 is 70, so we don't have that amount. We've only got 68, so I can only put 35 in once again. 1 times 35 is 35. Subtract. Every time we subtract, we drop down the next digit. This one's kind of a big one. I think this is where kids get stuck because they don't realize that this is where a quick mental strategy can be useful. We know that 35 times 10 would be 350, which is pretty close to this, but too big. So because times 10 would just be a little bit too big, I'm going to try 35 times 9. Working that problem very quickly over on the side, I got 315, which is just under this. So we do have enough. So 35 can fit into 332 9 times. 9 times 35, subtract. Every time we subtract, we drop down the next digit, but there's nothing else to drop down, so that means that we're done. I know that we still have this 17 left over, but that just means that it's a remainder. That just means that 35 could have fit into 4,182 119 times with 17 left over, which would be not enough to make another group of 35. And our remainder should always be smaller than the divisor, because if it was bigger, then that means that we could have made another group, which means that there must have been an error somewhere along the way. The next strategy that I'm going to show you for 4-digit by 2-digit division is going to be partial quotients, or the Big 7 method. So if you remember, we set it up very similar to long division, except we want that bar going down the side to make a Big 7. So if you remember from the last partial quotients problem that I showed you, this is all just a game of mental math. We want to get this number down as small as we can by multiplying by 35. So to start us off, 35 times something needs to get us really close to this big number right here. Off the top of my head, I know that 35 times 10, 350, wouldn't get us very close. So I'm going to bump up to the hundreds. 35 times 100 would get us pretty close, 3,500. So I'm going to start with that. Remember that whatever we're multiplying by goes on the outside and becomes a partial quotient that will get added up later. Make sure that you're listing every time you multiply something times 35, or else it will throw off your final quotient in the end, which means you'll need to go back into your problem and need to try to find the partial quotient that you accidentally left out. So 35 times 100, subtract. So now we have 682. I need to again think of something that I can multiply 35 times to get close to this number. I know I can't use another 100 because that number would get me way too big, so I'm going to bump it down to a 10. 35 times 10 is 350, and then we subtract. Now we're left with 332. No, I can't use 100 because that number's too big. I can't use 10 because 350 is also too big. But if you remember from the long division problem where I did 35 times 9 off to the side, I know that 35 times 9 is going to give me 315. So I'm going to use that. And then we subtract again. And we're left with 17, which is smaller than our divisor, so that will make it a remainder. But first, we need to go ahead and add our partial quotients. So our answer is 119 with a remainder of 17. The final strategy that I'm going to show you with 4-digit by 2-digit division is going to be an area model. So if you remember back to the other area model with division that I did, we start off by just drawing a box all the way over to the left. Our dividend, the bigger number, is going to go on the inside of the box towards the top. And our divisor, the smaller number, is going to go over to the side. Then, just like in partial quotients, we're going to try and ask ourselves 35 times what can get us close to this number. I'm just going to use the same partial quotients that we found the last time. So we started off with 35 times 100. So 100 goes up top to be one of our partial quotients. 100 times 35. Then we subtract. We're left with 682. We can keep going because it's bigger than 35. It can't be a remainder yet. So we're going to draw our next box. Whatever we're left over with goes to the top of the next box. Now we need to ask ourselves 35 times what gets us to or close to 682. Again, I'm just going to use the same ones as last time, and we picked 10. 10 times 35, subtract. We're left with 332. We can still keep going because it's bigger than 35, so we're going to draw our next box. 35 times something can get us close to 332. I've already done it for the previous two problems, so I'm going to use 9 again. But it truly wouldn't make a difference if you did like 5 and then 4, if you did 7 and 2. Even if you have different partial quotients, you would still have the same final quotient. 35 times 9, subtract. Again, we're left with 17 as our remainder. We know it's a remainder because it's smaller than 35. We couldn't make another group of 35 with 17, so that means that we're done. We add up our partial quotients at the top. That would give us 119 with a remainder of 17.